Hello, my name is Paul Berman, and I'm the Quality Assurance Officer for Animar Environmental Consulting. On this video, I will be discussing the need for dredging U.S. ports and harbors and one of the ways to ensure that dredging is performed in an environmentally friendly way. U.S. ports represent a vital component to our economy, national defense, and recreation. They allow for a diverse range of ships and vehicles engaged in numerous activities such as cargo ships delivering goods to and from overseas, providing ports and support services to the U.S. Navy and Coast Guard vessels, cruise ships boarding passengers for week-long trips, small private boats engaging in recreational activities, and fishing boats bringing in and selling their catch for the day. In order to accommodate all the ship traffic, U.S. ports routinely dredge accumulated sediment. The material dredged from U.S. ports and harbors typically consists of sand, silt, and clay. This is a model of a typical dredging operation. In this model, we have some fine-grained material at the top. This is silt and clay and is usually the maintenance material. Down below, we have the native sand or coarse-grained material. This will be left alone, and up top we have the dredge that will remove the maintenance material. The volume of dredge material from a single harbor can range from less than 1,000 cubic yards for a small private marina to many millions of cubic yards for a single commercial U.S. port. By way of comparison, a large single-family home has a capacity of approximately 800 to 1,000 cubic yards when filled completely from the floor to the ceiling. Large football stadiums have capacities as high as 500,000 cubic yards when filled from the ground level to the top row. Once the material has been dredged, it must be transferred to a different location. One of the most common and convenient locations, particularly for larger dredging volumes, is in an ocean dredge material disposal site, or ODMDS. Other options, usually for smaller dredge volumes, are inshore or upland sites such as confined disposal facilities. The dredged material may pose potential problems, however, since it may contain contaminants that could cause harm to the environment, wildlife, and even people. In 1972, the U.S. government enacted the Marine Protection, Research, and Sanctuaries Act, which, in part, addresses dredged material maintenance. This was part of an international agreement known as the London Convention to Reduce Pollution in International Waters. Dredged material that is transferred to inshore or upland sites are regulated by Section 404 of the Clean Water Act. One of the most important tools used to evaluate dredged material for placement is a computer simulation, STFATE. This simulation uses data about the disposal site and laboratory results to model whether there will be any adverse effects from the dredged material. The actual calculations of the simulation look at up to 3 types of laboratory measurements of the sediment. The first type needed is the physical makeup of the sediment. As mentioned earlier, sediment is typically made up of coarse-grained material such as sand and fine-grained material such as clay or silt. The other laboratory measurements needed are made from a mixture of dredged material and site water. This mixture is called an elutriate, which is used to simulate the dredging process. So in order to prepare an elutriate, we take 1 volume of the dredged material and we mix it with 4 volumes of site water. And in this jar, I have prepared an elutriate in accordance with that procedure. We have 1 volume of sediment, we have 4 volumes of water, and then what we're going to do, the laboratory will take this and they'll mix it. And ordinarily, the laboratory would use a mechanical mixer or a rotary mixer. And what will happen from this point is that it will be mixed for half an hour, and then it will be allowed to settle for an hour. The water is then filtered or centrifuged and tested for chemical constituents and toxicological effects. Chemical analysis is used to determine concentrations in the elutriate of constituents such as copper or pesticides. These concentrations are then compared to the National Water Quality Criteria. STFATE is also used to evaluate the effects of the elutriate on aquatic wildlife such as small fish, shrimp, and shellfish. The modeler, using the STFATE tool, will then simulate how the dredged material will behave in the water column for up to 4 hours after the sediment release. If the model shows that the sediment will not adversely affect the aquatic life in the immediate vicinity of the disposal, the sediment can then be approved for disposal by EPA. Sometimes the size and shape of the site or site conditions require that the dredged material be modeled at a different location. This may occur, for example, if there is high current at the site or if the water depth is shallow. STFATE's input can be adjusted to account for the different locations. Our ports and harbors are an important part of our local and national economies. Ensuring that they are properly dredged on a routine basis is vital to ensure that the services they provide can continue without interruption. Performed responsibly, dredging will not only be an important part of the economy, but will protect the environment as well.